Hello everyone, welcome back to my channel. If you're new here, my name is Stefan, and today we're going to look into the connection between electromagnetism and earthquakes, because just recently we had a massive 7.8 magnitude earthquake that struck central Turkey. There was a huge earthquake swarm that happened afterwards, and this is a really good opportunity to go deep into the connection between the Earth's natural electric currents, known as telluric currents, ELF energies like we see here on screen, which can be preemptive and actually predate an earthquake, and they can be used as a diagnostic signal for when an earthquake might happen. And this was, you can see the earthquakes here. This was like 4 to 6 hours before the earthquake. Very, very large, collected in Italy. So we're gonna go over that. We're gonna go into the connection between earthquake electromagnetism and biologic systems, aka you, and I have a personal anecdote to share there. And we'll be looking at a variety of data sets. Here we have some data from Tomsk, Russia, which was further away and still collected some preemptive earthquake signals, as you can see here, and also a very notable burst of energy in the Schumann resonances starting at the exact time of that earthquake. Huge qualities, off the charts, really interesting. Some post-earthquake ELF waves, post-earthquake electromagnetism that we see here, also from Cumiana, Italy, which is closer than Tomsk. These are the earthquakes. These are the distances from the receivers. And then we'll also do a large research review. So you can consider this a comprehensive guide to pre-earthquake phenomenon, to earthquake electromagnetism in general, the connection between the Earth's telluric currents, earthquakes, seismic stress, ionospheric disturbances. This will get you to the front lines. I suggest you watch this entire video. If you do, you will be at the forefront of understanding in regards to this field. So buckle up, Buttercup, get ready. We're gonna dive right into this. So this is our first data set that we're gonna look at. This is a pre-earthquake ELF signal. ELF stands for extremely low frequency. This is the 30 to 30 hertz range. And actually this goes beyond the ELF range because you can see here our frequency scale goes past 100 to 105 hertz. So this energy burst here that we see, this higher power, intensity, magnitude, burst of light photons that was observed in Cumiana, Italy, about 2,600 kilometers away from the site of earthquake rupture in Turkey. This is 2 hours long. This is a power burst going all the way from 0 hertz past 105 hertz. Very huge burst of energy. You can see the vertical geophone here picking up a lot of disturbance. And then you can see our Schumann resonances going from 0 to 30 hertz here on top. So a more precise frequency window, and you can see the unsettled conditions that were existing in the ELF spectrum right there. This is pure ELF spectrum right there. There is our second mode of the Schumann resonances. You can see this burst showed up there. And then there was this period of quiet. So the quiet period, the period of quiescence during the actual earthquakes. There was a magnitude 7.8 that occurred at 1:17 UTC, so early in the morning for Turkey. That was the most destructive earthquake. My condolences to everyone that was affected by that earthquake. Very, very tragic, huge loss of life, massive destruction, because it was then followed immediately afterwards by magnitude 6.7 earthquake at 01:28 UTC. So 11 minutes later, another huge earthquake struck. Remember, a magnitude 6.7 earthquake is weaker than a magnitude 7.8, and it's a kind of exponential scale. So this earthquake here was actually 45 times stronger in terms of its energy release than this magnitude 6.7. Neither of them would you ever want to tussle with. So what's very interesting though is this huge burst of activity that we saw in the ELF spectrum and beyond in the Schumann resonances. It's not common to see anything like this. There was no lightning activity in the area at that time. I checked. That is what you might see with lightning activity because that releases a lot of light photons across these parts of the light spectrum. But we did not see this. So This right here is earthquake related, almost certainly. This earthquake struck central Turkey at the triple junction between the Anatolia, Arabia, and African continental plates. So a big triple junction earthquake, and these were observed 4 to 6 hours before. The general research and scientific observations that have been made have shown that you can see these ELF energies and these ultra low frequency energies in the hours, days, and sometimes even weeks preceding an earthquake. In effect, the higher the magnitude of the earthquake, the more likely you're going to see these energies predate the earthquake further out in time. So this was very notable, and certainly if you were omnipotent, this would have been a warning sign to you. And then just 4 hours later, at the end of this energy burst, we get our earthquakes. Now, if we move over to Tomsk, Russia, first I'll show you where these monitoring stations are. In fact, this is the central location for this earthquake swarm. You can see the earthquakes here. These are the 7 largest earthquakes that hit central Turkey on February 6, 2023. Again, we zoom out. Here are our monitoring stations. Here's Cumiana, Italy, 2,600 kilometers away. And here's Tomsk, Russia, 4,100 kilometers away. So fairly close by. They're not on the other side of the world. They're also not just 50 kilometers away or 7 kilometers away. And we'll talk about why that's relevant in the research review. So if we go to our Tomsk, Russia dataset, you can see here, this is February 2nd. So this is 4 days before the earthquake, almost exactly, because this is local time for Tomsk, Russia, which is UTC +7. And you can see that these pre-earthquake signals, which are very anomalous, you never see this type of stuff, almost never. They start at around 7 o'clock in the morning. So 7, 8 o'clock. So almost exactly 4 days before this earthquake struck, we see these very unusual streams of energy resonate across the entire spectrum from 0 to 40 hertz. This is light energy here that we're seeing. So blue is low power vibrational photons, green is higher power, and then white is the strongest and most powerful. And this is measuring the vertical component of that light field. So we see 2 right here close together, centered around 20 hertz. There's a line at 20 hertz because that's a harmonic from the power grid, and the Schumann resonance at 20 hertz stacks on top of that, or you can think of it the other way around. And then we see this burst here, that burst there, and also a very strong one here at around 36 hertz, which is not measured by these qualities that they collect with the space observing system. But what's notable with these qualities is you can see that mode 1 here goes to 10 at the high, which is about normal. Mode 2 goes to 13, 14, again within that normal range. Mode 3, 20 hertz, goes to a quality rating of 250. Which I have never seen before. I've seen qualities up to 50. I've been tracking this for a few years. Never before have I seen qualities up to 250. So this is a huge, highly significant and highly unusual burst of energy that was captured in the Schumann resonances 4,100 kilometers away that predated that magnitude 7.8 earthquake in central Turkey. Magnitude 4 also went to a quality that was very high, 59, not 250, but 59. And what's notable about this is that these frequencies, 20 hertz, 25 hertz, that range, that is the range that is associated with pre-earthquake phenomenon. Based on the best scientific observations that have been made, one of the limitations is that we don't have these monitoring stations everywhere. And this energy is also very localized to space-time. So if you don't have a monitoring station right on top or near an earthquake when it happens, you're missing a lot of valuable data in effect. So we were still able to see these signals 4,100 kilometers away. Very notable. What's also really unique is that on the day of the earthquake, February 6th, you see that right here, at exactly 1:17:35 UTC, which is when the earthquake ruptured. If we line that up, we see that there is another very, very strong burst of energy in the Schumann resonances. This stream of energy starts at mode 4 at around 24, 25 hertz, and then moves through mode 3 at 20, nearly touches mode 2 there at 14, and then goes back down in frequency, or rather goes back up in frequency to where it started across time. And this is nearly, it goes from about, let's say, 8 to 14. So this is nearly 6-7 hours of disturbances in the Schumann resonances in this frequency band. You actually can see like the harmonic of it here and barely there. It's covered with the text, but it's right there. And then also you can see it right here. This one's a little more obvious. So it's not just in that frequency range. You get that repeated across the entire ELF spectrum, just like you do with this one. The only difference is that this occurred at the commencement of the earthquake, and then afterwards we see strong increases in mode 2 at 14 hertz. So if we look at the qualities for this event, you can see that they're quite elevated. Not like they are here. We're not seeing 250 or 59, but we do see 38 for mode 3 at 20 hertz and 30 for mode 4 at 25 hertz. We do see this big, really nice increase in qualities. This is the magnetic component we're looking at, the horizontal magnetic component. We see that big increase for mode 1 up to 14.6. After the earthquake, it starts right around when that earthquake begins, and then it charges up, and that is likely due to this harmonic here reaching a peak there. So very, very interesting that we are not only seeing pre-earthquake phenomenon so far away from central Turkey, but also phenomenon occurring during the middle of that earthquake swarm. There was also some post-earthquake electromagnetism. Rather, post-earthquake for the main quakes, there have been earthquakes popping off in Turkey since that happened. It is now the 14th of February, so it has started to die down both in frequency and magnitude. But in the few days after the first initial earthquake rupture, that 7.8 and 7.6 or 6.7, there was a whole bunch of earthquakes popping off, and we see in Cumiana, Italy, again, some more ELF activity, which is in line with what the research has shown, the scientific observations that have been made over the past few decades, in that ELF energy, that extremely low frequency energy and ultra low frequency energy, can be emitted before, during, and after an earthquake. So not as powerful as what we saw before here. The red is the high power and just completely goes off the charts. We see that starts to die down to lower power levels at 105. Here are the bursts in that 0 to 30 hertz range, but still very significant and at nearly the same time here at 2200. And this one started at 2000. So almost an exact repeat in terms of when it started. Again, the key observation is that this is going to a very high frequency range, all the way from 0 to 100, which is very similar to lightning activity. A lot of people think, mistakenly, because they haven't done the research, that the Schumann resonances and ELF waves in this 0 to, let's say, 100 hertz band is really only generated by lightning strikes, because lightning produces a whole bunch of photons across a wide frequency range, going all the way from near 0 hertz up to gamma rays. But in fact, there are a lot of things that produce ELF energy, your brain being one of them. So earthquakes, it seems, can do that. Telluric currents in the Earth's surface seem to be able to create that. The ionosphere is able to create ELF energy, and here we see that showing up again in Cumiana. So this is the earthquake location. Just want you to quickly see this, because here is the magnitude 7.8 and then the 6.7 right back to back, and then the swarm shifted north, and the most notable earthquakes again were here. So we see that at 10:24 that day there was another 7.5, so just 0.3 less. And then there was the sequence going to here, which is at 10:26, 2 minutes later, and then we go to a magnitude 5.8, and then a magnitude 6, and then a magnitude, or maybe it's this magnitude 5.7 first, and then this magnitude 6. So overall, very interesting fault dynamics here at play. These two popped off. Then we had some earthquakes up here. And there was actually some earthquakes even down here as far as Palestine. And I was in Luxor, Egypt at the time. So I'll talk about how I felt during this earthquake. I did not feel the earthquake in regards to shaking, but I had a biologic effect from that earthquake. So we will go into that with this research review, and we will come back to this data so we can have a little bit better understanding just to look at it briefly. So let's do that research review now. We're going to begin our earthquake electromagnetism research summary with some general information, and then we're going to look at a few different studies, which I have the titles of here, and then the DOI links or the URLs down below. So things that I've highlighted are a little bit more important, but overall we're just going to read through this, and by the end of this you'll have a pretty good understanding of how telluric currents, electric currents in the earth can trigger earthquakes. So to start off, ELF stands for extremely low frequency. That's 3 Hertz to 30 Hertz. And then ULF stands for ultra low frequency, which is 300 Hertz to 3 kilohertz. This ULF has also been used to describe frequencies below 3 Hertz, like sub 1 Hertz. So there's a little bit of confusion there with the ULF, but overall we're looking at radio waves that exist below 3 kilohertz. And really we're looking at radio waves that exist below 100 hertz. So keep that in mind. Okay, rocks produce an electric current when stressed. Why? Because rocks are a collection of mineral assemblages, which fundamentally are molecules that have atomic bonds, and when a stress is applied to those atomic structures, it can change how electrons behave. And therefore, when electrons are changing their orbital clouds and their quantum states and their spin resonances and things of that nature, they produce electric currents. So rocks produce an electric current when stressed. And an earthquake, of course, is created from a buildup of stress in the earth. The conductivity of the lithosphere, Earth's interior, increases with depth because temperature and pressure increase. Localized lithospheric conductivity further depends on elemental and mineral composition, with porosity, water salinity, and iron concentration being the primary factors. Porosity and water salinity are very relevant in like the top 10 kilometers or so, and then they become less relevant because the pores get squished out. The electrical conductivity of the deep mantle is 2 orders of magnitude higher than that of the shallow mantle, with a transition depth of 670 kilometers. Conductivity is a measure of the ability to conduct an electrical charge, aka how well can something move electrical current through it. And therefore, if conductivity goes up, then you can have stronger electric currents. The reason I mentioned the mantle here being higher in conductivity, 2 orders of magnitude higher, is to show you that the surface of the Earth is actually not that conductive as compared to the mantle and then the core, where the Earth's magnetic field is generated, which is highly conductive. So conductivity increases with depth. And because conductivity increases with depth, you're going to expect to see larger and larger and stronger electric currents deeper in the Earth's lithosphere. Okay, in order to generate sustained electromagnetic emissions, sustained electric currents must be able to flow. Generation of electric potentials in the Earth's crust lead to the generation of electric currents through the movement of charge carriers in the rock. In other words, potentials come first, electric currents come next. An electric potential or electromagnetic potential is effectively the same as like a resting potential, like a potential energy. You have a weight on a shelf, and gravity gives it potential energy. You push that weight and it falls down. It's the same with an electromagnetic potential. If it builds up, now there is a possibility for that charge to move to an opposite electric magnetic potential. So those potentials need to be built before an electric current can connect the two and equalize them out. So again, potentials first, electric currents second. Whenever an electric current flows, a magnetic field is generated. This is Faraday's Laws 101. If the current flows steadily in a DC direct current mode, the magnetic field is steady. If the current fluctuates, electromagnetic signals will be emitted at the frequencies of the time-dependent variations of the current intensity. So if the current has a variation on the span of, let's say, a minute, then the frequency is going to be whatever that 1 minute long period is. This basic principle applies across the frequency spectrum. And in the Earth, we have low frequency signals that are produced because the currents have very long time fluctuations. So you see these ultra low frequency and extremely low frequency waves, and the higher frequency waves that are created aren't able to penetrate all the way out to the surface, typically because they're higher vibrational and therefore they get absorbed into the rock surrounding the location in space-time of where they were generated. So it's only the lower frequency waves which are able to pierce out beyond the lithosphere and into the atmosphere and then beyond. The prime source for short-term magnetic field changes at the surface of the Earth are variations that come down from the ionosphere. That's relevant in just a little bit. Electrical activity is one of the hallmarks of life and of space. It is critical for the transfer of information. That's also going to show up at the very end. Okay, so Earth electricity, a review of mechanisms which cause Telluric currents in the lithosphere. This is a fairly good research review that this one grad student did. There are a couple little mistakes in there, but I think overall it gives us some stuff to think about, and it gives you a good base of information to go with. So, Telluric currents were originally defined as natural electric currents passing through the Earth's soil or rock layers or bodies of water. Now any electric current in a planet or on it may be classified as a Telluric current. So I think most people, when they discuss like the ionosphere, they'll say an ionospheric current, currents in the ionosphere, and they'll stick to Telluric currents in regards to any electric current moving through the lithosphere or water. But yes, those are Telluric currents. Electric signals do not carry much of a marker to indicate how they are generated beyond their magnitude, aka their power or their intensity, their frequency, and their polarization, which makes their origin difficult to ascertain. That's one of the big problems with this and why this is still such a new field that a lot of people just haven't done the research yet, so therefore they kind of don't believe in this stuff, even though there's decades of work behind this by a lot of really, really good scientists and geophysicists and biologists. Okay, 3 types of seismic electric signals have been reported from a network of monitoring stations in Greece. First, a gradual variation in the electric field of the Earth has been recorded on the order of weeks or more before an earthquake. And this is a voltage an order of magnitude higher than other purported precursory seismic electric signals. This occurs rarely. Secondly, presumed seismic electric signals on the order of hours to 11 days before an earthquake with an order of magnitude in the millivolt range occur commonly. Third, a short duration pulse, 1 to 4 minutes precedent to seismic waves with an order of magnitude in the volt range occur rarely. And in the volt range, that's pretty significant. All 3 are low frequency signals less than or equal to 1 Hertz. So these are almost like the field lines of the Earth's magnetic field, those field line resonances. They have frequencies sub 1 Hertz. Similar seismic signal data have been reported in Japan using the same method. We're going to go into that. That's ELF signals though. Seismic electric phenomena may have immense practical applications for public safety in distinguishing between purported seismic electric signals and other electrical events might allow for successful earthquake forecasting. That's the holy grail, people. We can save a lot of lives and save a lot of money and prevent a lot of damage if we have earthquake forecasting that works. And it is not impossible. It is physics. electric currents in the Earth crust, and the generation of pre-earthquake ULF signals. And this is a good one here, so this will really give you a better understanding of this entire field here. Before earthquakes occur, tectonic stresses increase in some parts of the Earth crust while the stresses in other parts remain relatively static. Common sense, you would hope. During dynamic stress buildup, electric potentials increase in the most stressed region and spread into the surrounding less stressed regions, increasing the size and relevance of the Earth circuit being created. So this buildup of stress is hanging out in one part of space-time, and then the other parts are remaining static, but the electric potentials spread out. Much easier. Electrons are immobilized in p-type semiconductors, a condition which persists from room temperature to moderately elevated temperatures. A p-type semiconductor it's fairly non-conductive. However, when temperature is raised sufficiently, electrons are able to enter into higher energy levels and become mobile, transitioning rocks to n-type semiconductors, which are much more conductive. There is a P to N transition somewhere at depth in the mid to lower crust, roughly at the 500 to 550 degrees centigrade isotherm, at which typical deep crustal rocks transition from P-type to N-type conductivity. And if we assume a typical continental geotherm, that 600 to 550 degrees centigrade temperature range is reached at a depth of about 35 kilometers. So from this research paper, here is this graphic. You can see the upper crust is brittle, weak, depth 5 kilometers, middle crust, brittle, strong. Thermal is now 200 centigrade, water is boiling, it's hot, and this is a depth of 15 kilometers. This is all P-type. Then at the P to N transition, it's about 35 kilometers down. Below that, we get a ductile lower crust and then a plastic upper mantle. Currents flowing through the hot rocks below the PN boundary, as depicted in figure 5b, can be very, very large, reaching millions to tens of millions of amperes. So the electric currents flowing through here are very strong, and that's because electrons are mobile. They can actually move, whereas here electrons are locked in position, and the active charge carrier for the upper and middle crusts are what are known as positive holes, and they're able to move, but they're just not as good of a charge carrier as electrons. Okay, here's the next graphic. Depiction of a more advanced stage of the stress buildup across the Earth crust with dynamically evolving isobars extending downward and crossing the postulated PN boundary. These are the isobars. So here are those positive holes, those charge carriers. There's a buildup of positive charge on the surface before an earthquake, and that is what creates biologic effects like the ones that I experienced while I was in Egypt, just 1,000 kilometers away or so. So as the stresses build, these positive charge carriers radiate out, go to the surface, go forward, and then also go down to that PN transition, where then electrons are able to meet them. Positive meets negative, they balance each other out, and you can then have that circuit closure required to create the ELF waves, the electromagnetic waves needed, or at least not needed, but to generate those electromagnetic waves which then radiate out, and those potentially are what trip an earthquake as well, by overloading the atomic structures at critical fault zones. So here, if we look at this, let me see if I can get the text there at the same time. In fact, once the electrical connection is established through the downward expansion of the isobars, it is likely that the charge carriers flowing out of the stress volume that have spread far afield in the P-type conductive upper and middle crust will combine closer to the point where the circuit closure was achieved. So they start to get closer and closer. Therefore, the curved arrow indicating the flow of electrons will probably be much shorter, so this shortens, than depicted in figure 5b, giving rise to a shorter loop and therefore a more concentrated current source from where ultra low frequency emissions might occur. So if this current can become more concentrated, then the emissions become stronger. There have been reports on powerful ULF emissions shortly before large earthquakes, such as the magnitude 8 Guam earthquake of August 8, 1993, and the magnitude 8 Wenchuan earthquake of May 12, 2008. We're going to look at some case studies. We're going to look at Loma Prieta, Alum Rock, and then also the Kiki earthquake of Taiwan. The Loma Prieta magnitude 7.1 earthquake occurred on October 17, 1989, and it occurred along a horizontal strike-slip fault with a hypocentral depth of 18 kilometers. A ULF antenna was buried in the ground in the Santa Cruz Mountains of California, by chance only 7 kilometers away from the epicenter of the earthquake. The reason it was there is they were testing ULF transmissions with submarines, and what happened was the antenna started to receive ULF signals 16 days before the main shock of the Loma Prieta 7.1 earthquake near San Francisco. The ULF signal strength reached 55 nanoteslas per hertz shortly before the earthquake, and it still reached 40 to 45 nanoteslas per hertz about 48 hours after the shock, and these then faded away over the next 2-3 weeks. This is significant because of 55 and 40 or so nanotesla variation. That strength is quite significant in regards to the background electromagnetic field strength of the Earth. So it is well outside the normal range, it's anomalous, and this was all picked up back in 1989. Yet people still don't believe in how these ULF signals are created before, during, and after earthquakes. I think they need to go back to physics class. Okay, the Alum Rock magnitude 5.4 earthquake of October 30th, 2007. This is actually very interesting because this is a lower magnitude earthquake. It's below magnitude 6, and even then it still generated some really interesting ULF signals. So the earthquake began at a depth of 9.2 kilometers on the Calaveras Fault, which I used to live just nearby, part of the San Andreas Fault system in Northern California. And if air becomes heavily ionized, it becomes electrically conductive. This is important because you need circuit closure to occur for things like ULF signals to be generated. You need that current to be able to flow. So if the air is able to become conductive and host electric current, that's one way that a circuit closure could be achieved in a earth battery setup. ULF signals seem to occur during the time of the most intense air ionization. About 26 hours before the earthquake, the nearby East Milpitas air conductivity sensor started to record elevated concentrations of positive air ions. Nearby means just a couple kilometers away. At 20 hours before the earthquake, the air ion concentration became so high that the sensor went off scale and stayed off scale for 13 hours. So we don't know exactly what happened with the air ion concentration during that 13-hour window, but we know it is extremely elevated. The increase in air ionization was measurable over a wide area, as an air conductivity sensor in Portola Valley, 35 kilometers away from Alum Rock, also recorded an increase in positive air ion concentration. About midway into the 13-hour period of off-the-scale highest air ion concentrations, the magnetometer at the nearby East Milpitas site recorded a 30-minute long continuous train of high-intensity ULF signals with amplitudes up to 30 nanotesla in the 1 Hz frequency range. These ULF signals were confined to the immediate surrounding area of the epicentral region, as none of the other 8 stations showed simultaneously elevated ULF activity. And the magnitude of the electric current needed at about 10 kilometers to generate that 30 nanotesla magnetic signal at the surface was calculated to fall in the 10,000 to 100,000 amp range. So a very large electric current at around that depth. And what is important about this Alum Rock earthquake, there's 2 things. The first is that it was very concentrated. These ULF signals were very concentrated to the site of the earthquake. So let's say the monitoring stations like we have with this Turkey earthquake that are thousands of kilometers away would not have picked up any of this there. So if we want to better understand these phenomenons, we need a higher density of magnetometer and air ion concentration monitoring stations. The second thing that's important with this is an anecdote that on October, I think it was 25th or I think it was 25th of 2022. I talked about this in one of my other videos. My brother-in-law was in Palo Alto, and there was another earthquake on the Alum Rock, in the Alum Rock area on the Calaveras Fault of a similar magnitude. I think it was a magnitude 5.6 or something. And he came down and got really sick and was bedridden for 4 days after that happened. And he was just maybe 15 kilometers away from the epicenter of that earthquake. And he got blasted by these positive air ions, which have deleterious electromagnetic effects in the body. So we'll talk about that at the end of this research review, but just as a personal anecdote, he was bedridden for 4 days, didn't get up, didn't eat anything, he was feeling terrible. Something just became out of harmony with him, and also with his coworkers who he met up with. They all got sick during that time. So there is definitely overlap between Earth electromagnetism and the electromagnetic energies of the universe in general and your health. Okay, this is a really interesting one. Lots of great data with the Kiki magnitude 7.6 earthquake of September 26, 1999 in Taiwan, because they had just installed a island-wide monitoring station. So they collected a bunch of unusual data, anomalous data from this earthquake across all these different monitoring stations, which has been extremely valuable. This earthquake occurred along the Chalongpu, I hope I said that right, Chalongpu Fault, which is one of the thrust faults in Taiwan, and intense ULF signals with amplitudes up to 250 nanotesla. Huge. Preceded the Kiki earthquake for more than 7 weeks. Here we can see our magnetic anomalies. Back in August, again, the earthquake started September 26th. Back in August, we see these massive nanotesla deviations from the norm. There's kind of your norm right there. And just randomly going off, sometimes it's normal, then boom, ULF signal, normal, ULF signal. Then we see September start, we get a big burst at the beginning of September there, and then they really become notable right at the right at the beginning of this earthquake, and then afterwards. There's a really big one before the earthquake, or there's the earthquake, right? Earthquake, this is 26 right there. So I'm not sure how accurate this arrow is, but either way, you can see the ULF signals predate and also post-date this earthquake. You can see here that actually this is the really main trend where it actually stays down and does not go back to baseline at all. So really notable ULF activity observed in Taiwan around this Kiki magnitude 7.6 earthquake. Okay, during the last 10 days before the main shock, between September 12th and the 19th, ULF signals were emitted in such dense sequences that they merged into broadbands lasting 12 to 48 hours. I think this is that range right here. This is the 11th. So there's that section right there. The groups of ULF signals exhibit a relatively fast rise and slower decrease. Before the main shock, ULF activity died down to near quiescence, which should remind you of this period right here where it went nice and quiet. We had activity in the Schumann resonances and in the overall spectrum, and then really, really, really quiet right when those earthquakes struck in Turkey. Okay, both ULF activity and regional seismicity exhibit a clear correlation with the Earth's tides. This is important. This suggests that all three are linked. Of course, the tides are controlled by the moon. If the ULF fluctuations are due to stress-activated electric currents, one explanation is that they are controlled by the Earth's tides. This controlling effect would come from the weak gravitational pull that the moon and the sun jointly exert on the Earth's crust. Because the gravitational forces are relatively weak, the seemingly tight coupling between the tides and both ULF emission and regional seismicity comes as a surprise. So in effect, we just don't understand this well enough yet. Another explanation is that the water table moves up and down synchronously with the tides affecting the geomagnetic readings. Now, because we're at this section right here, I'm going to jump really quick to the SSGEOS website. This is Solar System Geometry Survey. This guy did a seismic planetary update on like the 3rd of February that blew up because it was almost like a prediction for this Turkey earthquake. That's how a lot of news sites ran with it. So this is interesting because he's done a lot of research into this and has developed a software that compiles all these different variables and then gives you like probabilities of where the likelihood of earthquakes or strength and where they might occur. So that's something for you to check out. Here you can talk about, talks about earthquake forecasting here. Very, very interesting. He recently just went viral. What I want to show you is this tweet from January 27th, 2023, which is before that Turkey earthquake, and his virality, which is, after 9 years of research, we have a much better understanding of planetary and lunar geometry that precedes large earthquakes. Lunar geometry in particular has been greatly underestimated. A great example of this is the 2020 case, which is now understood thanks to lunar geometry details. And I talked about the position of the moon in regards to this magnitude 6, 7.8 earthquake in my last video. So it was right around the full moon and right as the moon transited over the Sahara, one of the most resistive parts of the earth, we had that earthquake. And it looks like SSGEOS also has recognized that lunar geometry is a very large factor in earthquake activity. So shout out to them. There's a lot that we don't know, but there are some of us who are looking into this more. Okay, we are going to look at the next research study, the summary of it, which is anomalous effect in Schumann resonance phenomenon observed in Japan, possibly associated with the Kiki earthquake in Taiwan. So this is Schumann resonance data, not ULF data, for this Kiki earthquake. And I hope you've been enjoying this really in-depth, comprehensive guide on earthquake electromagnetism. I hope you're still here, you're buckled up. If you like the video, please click that like button and subscribe to the channel to see more things like this. Okay, very anomalous effects in the Schumann resonances were observed in Japan in the period of time around 2 large land earthquakes. The first being the magnitude 7.6 Kiki earthquake at that date in September, and then the magnitude 6.4 Kiayi earthquake on the 2nd of November 1999, so just a couple months later. These anomalies were characterized mainly by the unusual increase in amplitude of the 4th Schumann resonance mode at 25 Hz and a significant frequency shift of its peak frequency by about 1 Hz from the conventional value on the BY magnetic field component. Anomalous Schumann resonances signals appeared from about 1 week to a few days before the main shock of the Kiki earthquake. Okay, does this look familiar now? Here we have those anomalous signals 4 days before in that frequency band. Here we have them across the entire frequency band. And here at the beginning commencement of this earthquake, we again have anomalous energy in that 4 to 2 Hertz, or mode 4 to mode 2, that 25 to 14 Hertz range. Okay, let's go back to this. So, September 10th, 1999, normal conditions. Here is the power spectral density plot showing the Schumann resonances. This is 0 Hertz. This is intensity as measured in decibels. And you can see the first mode there rising up, goes down. Mode 2 there at about 14. Mode 3, mode 4, and then we see some activity here. Okay, on the 16th, here is what that power spectral density plot looked like. Big increases starting from just after mode 2 at around 16 Hertz, going all the way up to about 26 Hertz there. and this component about 25 hertz, and then going back down to its about normal value for 33, 35 hertz, which is mode 5. So big sharp increases in modes 3 and 4. And again, that is exactly what we see here. Going right from mode 25 hertz all the way to about 16 and then going back down. And we see this starting right here at about 16 hertz. Wow, okay. As is seen in the above figures, the fourth harmonic at approximately 25 hertz is extremely enhanced in the dynamic spectra on October 16th, 5 days before the Key earthquake. An important point for this anomalous Schumann resonances phenomenon is if the anomaly is naturally repeated. Does it happen more than once, or is this a one-off? Well, with our magnitude 7.8 earthquake in Turkey in 2023, we saw this repeated. The intensity variation at the fourth mode with a peak on the 15th of September and then decaying for a few days might be associated with the Key earthquake, and an additional broad peak from the 22nd of September to the 26th. They say it's a little complicated, but this broad peak is overall one event, also occurred. An aftershock of the Key earthquake occurred at nearly the same epicenter on the 26th of September, which may suggest that the peak on the 22nd to the 26th is to be associated with the aftershock, but it may also possibly be associated with an after effect of the Key earthquake, like we see here, which is one day afterwards we see this ELF activity blast off. There is certainly earthquake activity happening, but maybe it's from the main earthquake. In general, I think you could say it's from the overall earthquake activity. During this time period, the ionosphere also experienced anomalous conditions. So we don't see that second broad peak because they didn't create that power spectral density plot. They just talked about it in their research paper, but that is basically a pre-signal, and then they also saw a post-signal. And of course, these researchers saw a whole bunch of pre, post, and a little bit of during too. Okay, ionosphere. The ionospheric perturbations prior to the Key and Kia-Yi earthquakes. Ionospheric perturbations were observed 3 to 4 days prior to the Key earthquake, as well as 1 to 3 days prior to the Kia-Yi earthquake, which happened later. The geomagnetic field also registered significant disturbances after both earthquakes. So we have our KP index, which is a measure of geomagnetic volatility, going from 0 up to 10. And we see here our solar storm, solar storm commencement? Solar storm conditions. And then we see our Key earthquake. So our earthquake happens right there. This is our KP index. This is for the Key earthquake. And then we have solar storm conditions register in the KP index rising all the way up to about 8. And then it dies back down. You do see a general increase in the KP index in the days preceding that Key earthquake. But really it's like you have the earthquake and then you have this big increase in the KP index. Here we have our Kia-Yi earthquake, and we see the earthquake right there. Big drop in the nanotesla reading there. We also see that here, big drop slightly afterwards. And then we see again this corresponding big increase in the KP index. So geomagnetic storms can and often do trigger ionospheric storms, which disturbs the ionospheric electron density, changing electric field potentials. The strongest electric currents are related to lightning phenomenon or space weather, but they might also be related to earthquakes. If we go to some of these photos from the Turkey earthquake, we see the destruction here. It's really devastating. This is translated from Turkish to English, so there might be some spelling mistakes. But what I want to show here are some of the anecdotes of the locals. Green light after explosion of the earthquake. So some citizens were awake and they heard an explosion and in the same area they saw green light. So this individual here is right here. Abdullah Temilkan said the explosion was out here. There is no such thing. To see such a collapse. And there are those who actually saw it explode. He could not believe it. Green fumes came out of here. So earthquake, lightning. I made a video on that last year with an earthquake that happened in Japan. This incredible devastation, massive rupture zone through central Turkey, and that happened nearly instantly. So most likely triggered by electric currents overloading atomic structures in critically stressed fault zones. And potentially it was the moon passing over, which just was the final straw that broke the camel's back. And that actually makes a lot of sense because it would be the moon that has a regular motion over the Earth that could do that. So it would constantly just stress and stress and stress, and then it would be the most likely thing, or at least has a high likelihood of being that final thing because of its reoccurrence interval as it rotates around the Earth. Okay. Returning to February 6, 2023 in the central Turkey magnitude 7.8 earthquake, we're just going to look at the KP index for what we just experienced because we saw this. Well, here we see our KP index. And the red arrow right there is when that earthquake happened. I lined it up. And we see our KP index rose dramatically, aka geomagnetic volatility rose a lot for the entire Earth after that magnitude 7.8 earthquake in Turkey, and sustained too. It stayed elevated and then actually reached a high there on the 10th, which was during a very unusual solar phenomenon that has never been observed before. We're going to look at that in a little bit too. Again, this is a comprehensive video, so I hope you're learning a lot. If you like this, click that like button. Okay, lastly, nature of pre-earthquake phenomenon and their effects on living organisms. During buildup of stress, electric charge carriers are activated deep below. These are called positive holes. They're called positive holes because they're a place in an atomic structure where an electron is deficient. It's not there. So it has a positive charge, whereas normally it'd be neutral. Positive holes have unusual properties as they can travel fast and far into and through the surrounding rocks. And as they flow, they generate ultra-low frequency electromagnetic waves. And when they arrive at the Earth's surface, they can ionize the air, like was observed with Alum Rock and with a bunch of other earthquakes. The air above the epicentral region of an impending major earthquake often becomes laden with positive airborne ions. And medical research has long shown that positive airborne ions cause changes in stress hormone levels in animals and humans. Okay, that's what I experienced. I'll get to my personal anecdote with Egypt in just a little bit. It is important to first recognize that EM waves are time-dependent phenomenon. So you have the crest of a wave, you have the trough of an electromagnetic wave at specific points in space-time. They're time-dependent. And their effects on temporally organized biochemical cycles in living cells, which are also time-dependent, such as the reduction-oxidation cycle, can generate quite opposite effects depending on their phase relationship. Are they in phase? Are they out of phase? I hope this is making sense. It gets kind of in depth. I'm doing my best to make this easy for the layman. Okay, the redox cycle, also called the metabolic cycle, is the fundamental biochemical process that controls the timing of all biochemical reactions in living cells. Trillions and trillions and trillions of reactions every single second, which include energy production, ATP, RNA transcription, and DNA replication. Through temporal coordination, a chemical conflict between the reductive and oxidative reactions is avoided. You don't want to be out of phase, basically, or else you hinder the flow of energy and information within cells and between cells. while at the same time a coherent or interfering transfer of energy is enabled between the ambient natural electromagnetic field and living cells. The interaction between electromagnetic waves and electron transport in redox reactions clearly depends on the phase relationship between oscillating systems. Therefore, whether or not ambient non-ionizing electromagnetic fields are able to affect biologic processes and organisms is very sensitive to the resonance at that moment, which occurs when the organismal physiology is able to transfer energy from the ambient electromagnetic field in tune with the electromotive force across membranes. And this gets into bioelectricity and morphogenetics and all this stuff. It's really, really fascinating. I have a lot more videos to make on this. In other words, if ambient electromagnetic fields and bioelectric fields overlap at the same frequencies but are out of phase and they deconstruct, just like playing noise-canceling headphones you can think of. It plays a sound wave opposite of the one that's coming in and therefore it makes it silent. Energy and information transfer within and between cells is disturbed due to this deconstruction of electromagnetic waves, which impairs metabolic functions and causes biologic disturbances great enough to be felt, and for those to overall create larger disturbances, like let's say coming down and getting sick. Positive airborne ions are known to have pronounced and generally detrimental physiological effects. Personal anecdote. I was in Luxor, Egypt on February 4th and Aswan February 5th and 6th. I started to get sick with an upper respiratory tract infection on the night of the 4th. It wasn't that major, but I definitely noticed inflammation up in my nasals. And then on the 5th, when I traveled from Luxor to Aswan, it was pretty mild. I had good energy, but I could still feel it. I was drinking a lot of water. But on the morning hours of the 6th, when the earthquake started, I felt terrible. I wasn't sleeping that much. I had a mild fever, hot flashes, stomach pain. At one point, I felt like I needed to vomit. I luckily didn't. And I just had these really overactive thoughts that I was doing my best to meditate through. I was only 1,500 kilometers away from the magnitude 7.8 earthquake epicenter, and I was next to the Nile River both times, which is relevant because it seems I was in an area that was close enough to be loaded with these positive airborne ions. I don't get sick often. I'm very, very healthy and conscious of what I need to do to stay healthy, and this really came out of nowhere right at exactly the same time as this earthquake, and all this evidence would suggest that this was certainly a contributing factor. Okay, intriguingly, the rotational frequency of the molecular enzyme motor called ATP synthase, which synthesizes ATP, oscillates at ELF frequencies. Animals can clearly respond to a range of different physical and chemical stimuli arising directly or indirectly from the stress activation of positive whole charge carriers. Indeed, understanding the nature of these enigmatic electronic charge carriers in rocks provides insight which was not previously available into the modulation of redox states in the Earth's ecosystems from the global scale down to the atomic level. And I would say this actually goes beyond the global scale. These interactions are universal in nature. I think this is all connected. We just don't simply have the ability to perceive and understand these higher orders to the degree that we would like to yet. That's just going to require more insight and more scientific exploration. Why do I say that? Well, let's examine an interesting, never before observed solar phenomenon that occurred on February 10th, just 4 days after the notable earthquake swarm first struck central Turkey. February 10th, again, right here. So, check this out. This is the sun on February 10th, and we see this vortex blast off right there. NASA scientists have said they've never seen anything like this. I wish I could slow this down to be even slower. Maybe I can. I don't think so. But we see the corona swirling, almost forming a tornado at the pole of the sun. And then there's a massive coronal discharge up, out away from the Earth. This is like, you could say, going north into the solar system, really going perpendicular to the plane of the solar system. So again, let's just look at this because it's so fascinating. There we are. Wow. That just happened. Solar cycle 25 has been crazy thus far. It's way stronger than predicted. I've been making videos on that. I suggest you give those a watch. This occurred just 4 days after this massive earthquake swarm. And there is evidence, a lot of evidence going back 50 plus years, that solar activity has a strong influence on earthquake activity on Earth. So one last time, wow. Big, big, big. Okay, so I want to show something else really quick, which is interesting. Let's look at this interactive 3D earthquake viewer. I put it for our region, and I put the window for the day before to now, but I also made it so it's just earthquakes that are magnitude 5 and greater. So minimum earthquake magnitude is 5. Here are our earthquakes. You see red are magnitude 6 and up, and blue are purple, or whatever that is magnitude 5 and up. So let's go through time here. We start at 0. There's our first magnitude 7.8 earthquake. And then we see the earthquakes move up closer to the surface. See that nice little boom, 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 just like that? It's like there's an energy tendril that shot out from the lower part of the crust upwards, going towards the surface before then the earthquake swarms shifted over to the side over here, where there was also another big deep earthquake. There you can see that's actually the second deepest earthquake. Our deepest one's right there. But this energy tendril that initially started this whole swarm, it's very fascinating. And if we look here at our latest earthquakes from the USGS, we see that earthquake swarm. We can see also the earthquake that happened in Palestine there, going all the way down and up into Georgia, even a little bit there. But I have this already at the right time. We see our first earthquake there. This is our 7.8, 17.9 kilometers. Next one that happened just 9 minutes later, 17 kilometers. Then 2 minutes after that, 14.5. Then 8 minutes after that, 10 kilometers. So that right there is your energy tendril. That is your 1, 2, 3, 4, 5, just like that. That is that energy current moving up, overloading the fault, and triggering a series of Earth displacements, seismic displacements, before enough is overloaded to the point where then the overall earthquake swarm can commence in this part of Turkey. You can see most of it happened there, but it started by going like this. So if we go back to our data, I think we can understand this a little bit more now. Let me zoom in here. We had large electric currents in the Earth's surface that were being generated as these circuits got closed. And as a result, they generated ELF waves, which were of a low enough frequency to be able to pass through the Earth's surface out into the atmosphere, where they were then observed as far away as Cumiana, Italy, and Tomsk, Russia. And the reason why they can be measured that far away is because these waves resonate really nicely in the Earth, and they have a very low frequency, so they do not get absorbed into the air easily. So once they're out of the Earth's surface, they can move across the Earth at the speed of light very quickly and not die out and be observable signals. So we had that happen 4 to 6 hours before the earthquake. We had these signals show up for days before the earthquake and also during the earthquake, and we also had them show up nearly a day later. So that is your research review on earthquake electromagnetism and the biologic effects that it can create through the creation of positive air ions. I do want to finish this video by saying that everything that's said here is certainly not comprehensive for the phenomenon that we're discussing. Everything that this actually is more and also different than what is described here. So this is just a preliminary understanding. There's certainly things that are that have a big influence over these things, like the position of the moon, the sun, the solar cycle, galactic plasma sheets, and all this stuff that we just don't understand yet. But these are some of the things that we have identified that are important, that clearly have an influence. So these telluric currents that move through the surface of the Earth that are able to overload high stress zones and break down atomic structures and accommodate that rapid seismic motion and release of stress. Basically, it's a huge, 1,000 atomic bombs worth of energy being released in the Earth's crust, and then that radiates out. And you could think about how the earthquake swarm of lower magnitude is actually because a lot of that energy is then reabsorbed into the rock in the surrounding locations in space-time, which then overloads those fault systems, and so on the reaction goes. But a lot of that energy is able to pierce all the way out into the atmosphere, where then that ELF energy is able to ionize the air and create biologic effects that are observable, like I certainly experienced, because I was not happy for about 48 hours. And in the case of the Alum Rock earthquake on, I think it was October 25th, 2023, my brother-in-law was bedridden for 4 days after that one. And he was like standing on top of that epicenter. I was 1,500 kilometers away or so. So I hope you enjoyed this video. If you like this video, please click that like button and subscribe to the channel for more videos like this. I'm going to be doing a lot of deep dives into these topics, not only on earthquake electromagnetism or the Schumann resonances, but also into bioelectricity. And there's a variety of topics that I think all connect, which I explore on my channel, all related to energy. So if you like this, again, I hope to see you around. Please leave your comments below. If you were affected by the earthquake, like to hear your personal anecdote as to what happened with the shaking and how you felt. And again, my deepest condolences to everyone that was affected by that earthquake. I will put a link in the video description of a place where you can donate some money to the the people affected by that earthquake. So I hope you can match my donation. I'll donate 20 bucks. I hope you can match that donation. And let's just start a general conversation here. I hope you enjoyed this deep guide into this. And again, subscribe to my channel and you'll see more things like this. So thanks for watching this video. I'll see you in the next one. Have a great day and ciao.